Hello everyone. In this video we will discuss about the other structure of the page table implementation. So we have actually three different structures for the page table implementation. First one is multi-level, and then hashed page table, and then inverted page table. So in case of multi-level, why we are actually going for three different structure of page implementation, which means if the page table needs more number of entries, suppose if you're working with a very large virtual address space, then you must need that very large page table entries. So in order to hold a large number of entries in the page table, so we are going with the different structures. So multi-level means on a hierarchical basis we can store all the pages in the page table, so we can have more number of entries even if you are using different levels, which means from outer level to inner level, or else from first level to second level, and it has goes on multi levels. So it is not necessary to keep only two levels, or it is not limited at all. So we can have any number of levels in case of multi-level structure. So the another structure of page table implementation is hashed table. So this hashed table is nothing but, so here we have the traditional page table, which is nothing but all the entries will be stored in one page table, and from that page table we can refer the corresponding frame number in the physical memory. There we can access any of the content, or if you want to execute any instruction that was stored already in the physical memory. Suppose in the hashed page table, how we are arranging all the page table entries, how we are arranging all the entries in the page table, which means depends on the hashing concept, which means there will be having some number of locations in the page table, and we are just going to provide one of the most important field in the entry is said to be key field. So the key value of each and every entry should be compared with the corresponding location of the page table. If it get matched, then this could be the correct or this could be the correct page frame number that we are referring. So this is how this hash table implementation works in the paging concept. So which means if you are referring one page table, I mean one of the entry in the page table, there we have arranged all those things in hashing concept in the way of how we followed the hashing. In the same way we just arranged all the entries in the page table, which means the key value and the corresponding location of the page table must be matched, must be same. So if it get matched, then the whatever the page frame number we have in that location, so that could be the content what we are searching. So that could be the actual physical address of that content. So suppose if it does not get matched, then what we have to do, we have to search with any other key field value which gets matched with the corresponding location. So this is what the hashing concept, and it also consists of one more field, which is nothing but what could be the next page table entry. So what could be the next entry in the page table, so it will have some linked list concept. So it will have a link from this address to the next entry's address. So this is what the concept of hash table. So in this way, what is the advantage we are getting for this kind of structure, which means we are not consuming more time for accessing any of the content from the memory. Suppose if simply we are comparing only with the key value and the corresponding location number, if both are same, then we can get that entry is said to be the correct. From that entry we can get the correct frame number, and the correspondingly we can get the actual content whatever we need. So we can get the actual physical address of any content or any instruction easily without getting much delay. So this is what the advantage we are getting in case of hash table. But even in this hash table, so it is we are getting the disadvantage as we are not we can we are unable to store all the number of page table entries, which means um, a lot of entries we are not actually storing at a stretch in the hash table, which means if we are actually following this linked list concept, so because of that we can store many number of entries. So that could be the advantage of this hash table. So let us go to the next structure of the page table entry. So that is a page table structure, which is nothing but inverted page table. So the concept of this inverted page table is the field value whatever we have for this entry of the page table, I mean inverted page table, is nothing but it consists of three fields actually. One is the process identifier and the next one is the page number, which means the virtual page number, and followed by the offset. Here D represents the offset, or else it is said to be the displacement, the distance between the starting address of that page and to the actual location of the any instruction or the content. So here why we have this process identifier, what is the need of including this process identifier as one of the field in the page table entry. So here, which means we are not going to store the entire amount of process. I mean the pages, whatever we have in the virtual address space, we are not going to store all the page entry in the page table. We are going to limit the number of page entries, which means we will be having the entries of the pages that were actually stored in the real memory. So which means in the main memory, what are all the pages we have, only those pages entries will be stored in this page table. So this is what inverted page table. So from this we can get we can store, so we can easily access the content whatever we are storing, and also we will not be getting the page fault. Why? When we will be getting the page fault, which means if the referred page is not available in main memory, not in the page table, if it is not available in the main memory, then it is said to be a page fault. But here the page table entries will be consisting of all the pages that were stored already in the main memory. But what happens here, what is the problem which we are getting in this inverted page table? Though we have very large capacity of the virtual address space, so there could be a million number of pages that were available, but here we are limited, we have not stored all the entries of those million number of pages. So we have limited to the main memory capacity. So whatever the capacity of the main memory, based on that how many frames which we have in the main memory, so only those entries will be available in the page table. So that was one of the limitation of this inverted page table structure. So here we have included its process identifier. So based on the process identifier, the corresponding page frame number can we can get it in this page table entry. Okay, so this is actually the logical address which is generated by the user. So that address will be represented as three fields. One is process identifier, then page number, and the next one is displacement, which is nothing but offset. So with this process identifier, we will be searching the corresponding entry in the page table, and from that there we can get the page frame number. It is nothing but the frame number which is stored in the physical memory, and from there we will be copying the content of this offset. So whatever the value of the offset, so that will be copied as it is to the physical address representation. So here we are just copying its content offset value. So from the same offset value we can use it, which means the starting address of the frame to that particular location of that. Based on this offset value we can get the particular location of any of the content. So one more disadvantage what we are facing in this inverted page table is nothing but, so since we have limited and also we have included this process identifier, and based on this process identifier only we are searching the page table entry here, isn't it? So this entries, all the entries in the page table can be arranged only in the way how we have arranged in the physical memory. So whatever the process we have in the physical memory, in the same set of process will be available here, and also it follows the same arrangement of the physical memory. So what happens here, the logical address whatever we are providing, so we need to search the entire number of entries whatever we have in the page table. In some cases, if it is available at the last entry as the last entry, we need to search or each and every entry separately. So here the accessing time will be more. In order to get the frame number, in order to get the corresponding frame number of the given logical address, which means the page number, so it takes more time in order to search the corresponding frame number, because based on the process identifier only we are searching, so it takes more time. So in order to avoid this kind of problem, so we can even combine the concept of hash table here in this inverted page table. So we can follow the hashing method to store all the entries. Even though if you're following the process identifier, we can also implement the concept of hashing. So what does hashing? It means the key value must be same similar to the location whatever we have for the each entry in the page table. So based on the comparison of key value and their corresponding location, so we will be getting the page frame number as soon as possible, which means more it is not the time consuming task, because only one comparison has to be done in order to get the page frame number. So very easily and also very quickly we can get the page frame number. So we can implement the hashing concept also in this inverted page. That is also possible, so that we can avoid the time delay of getting the page frame number. So what we are getting in the inverted page table, right? So this is what the different structure of the page table implementation. So far we discussed about the paging concept and how to do the mapping concept by using this paging technique, and what are all the different structure of the page table implementation. Thank you.